Welcome to our final Geoguessr General update. As a final recap, our project was attempting to determine whether neural networks can effectively identify geographic locations and cues, visual cues, and how well they can perform when compared to human players. Originally, we sourced a dataset from Kaggle composed of 50,000 images from 124 countries, though for our own scope, we limited this to 6 nations, one from each continent, with at least 1,000 images to source from. Originally, we proposed a traditional convolutional neural network. However, our final model uses a residual convolutional neural network that takes the GeoGuessr image as input and processes it and attempts to apply one of the 6 nations as a label to said image. Going directly into methods, we had to resize our images to a 224 by 224 dimensions to fit ResNet's requirements. We did not remove the HUD artifacts. That is because in all these images, these elements are stagnant and do not provide any further insight into the country actually being guessed in the moment. We sampled 1,000 images from each country to prevent class imbalance, as shown in the distribution graph provided, which shows a clear majority in Japan and a clear minority in South Africa. And we split the data 70, 15, 15 with a validation set for further hyperparameter tuning. We did also train our models from a variety of epochs from 10 to 120. And we reported a variety of metrics as well, using top 1 accuracy for performance, top 2 accuracy in an attempt to understand the model's thinking and decision making, and the per country precision and recall to understand the final model's preference when guessing locations for a given image.
We made many changes from our baseline to our final model. The first thing we tried was retraining not only the final classifier layer, but also adding the last block of ResNet 50 to give more of the structure a chance to adapt to the game. After a solid number of iterations, we found an incredibly promising model and decided to move on, try more architectural improvements. We tried adding extra MLP layers with and without dropout before the final classifier layer, adding extra bottleneck layers to the last block of ResNet, adding an additional block to ResNet, normalizing layers, full model fine-tuning epochs, different initial weights, different epoch lengths, and every combination of the above. Although some came close, nothing managed to top the model we got from our first architectural attempt. A combination of an incredible optimizer seed and Occam's razor gave us the model that best generalized data. And it looks like this.
So on the model's performance. Looking at the accuracy numbers with our new model, we were able to get 79% top 1 and 91% top 2 accuracy. So it's a 12% and 14% improvement from our baseline, respectively. Looking at the top 1 confusion matrix, we can first look at the accuracies by country by looking at the diagonals. The model performed the best at identifying Japan and the worst at South Africa, with a difference in 16%. Japan being the easiest is what we found in our human testing for us personally, and South Africa being the hardest was also the same result we got on the baseline. Looking at the rest of the matrix, we can see that there aren't any obvious mistakes the model is making to point out. Most common wrong answers happen only 13% of the time, and for each country, the model is fairly uniform in its misses, indicating no specific weakness in the model. Looking at the top 2 confusion matrix, it remains the best at identifying Japan, and France is also tied for the highest accuracy at 95%. Australia is a country that struggles with the most in this with this metric, with an accuracy of 81%. This matrix gives us a better idea of what the model is thinking and how the model is getting mixed up. When the image is from Japan, for example, the model is very often also thinking it might be France. This can also be seen with both South Africa and Australia, respectively, which is another common mix that we found in our human testing. It's very interesting to see how the model's strengths and weaknesses are not too different from our own strengths and weaknesses when playing the game. Looking at the precision and recall by country, for precision, we can see that France has the lowest, indicating that out of all the countries, the model is incorrectly predicting France more than other countries comparatively. This goes along with what we saw earlier in the confusion matrix. The model is commonly guessing France when it is actually Japan or Canada. For recall, we can see South Africa has the lowest, indicating that South African images are being correctly recognized the least out of any country. And Japan is the highest, indicating that the model is able to correctly recognize Japanese images the most out of any country. This number is the same as the individual accuracy per country as seen in the top 1 confusion matrix. Here are references, and thank you.
Warning, the following program is a short game designed to compare our GeoGuessr General against human players.
That's what I think.
Against
Yeah,
your
lots of fields. Okay, okay. Oh,
Japan.
this is Japan.
I think this is Brazil.
Brazil.
Yeah, Brazil.
Palm trees, yeah. Okay.
Japan.
Yeah, this
You
was
think so?
I'm
high
100% sure.
grass.
Oh, yeah, that kind of field, yeah. Okay.
Hmm. That was gonna be my.
Funny looking tree moment.
Oh, true, true.
Maybe. Yeah.
Hey, the model matched just band for band. That's crazy. That is
But we got 10 in a
insane.
row.
That, yeah, we actually have. That's ridiculous. That's ridiculous.